Hello everyone, welcome to the second video lecture series of current in series and parallel circuits. So recalling the previous lecture series, we discussed about resistors in series and parallel circuits. So I have a question, or let us see how this behaved as a recall. Here is a question which is put forth to you, that is a voltage of 4 volt is supplied to two resistors of 6 ohms and 2 ohms connected in series. Now calculate the combined resistance, the current flowing and the potential difference across the 6 ohm resistors. For the question number C, we will have the answer towards the end of this lecture series, the following lecture series, whereas now we can see how the first question can be addressed. That is A, the combined resistance. And you have the question here. You can see that there are two resistors, 6 ohms, 2 ohms are connected in series. So now what is going to be the total effective resistance here? Yes, the formula is R total is equal to R1 plus R2. So 6 ohms plus 2 ohms, which is nothing but the 8 ohms. Yes, so this is going to be the answer. 6 plus 2 is nothing but the 8 ohms. And I have the answer for the next questions too, but let us not discuss about it now. Towards the end, we will discuss. So now moving into the current in series circuits. So you can see there is a battery source here and a switch here and the current, total current I flowing in it. And there are three resistors R1, R2 and R3, and for easiness it is called as just R alone. And the current flowing through these resistors becomes I1, I2 and I3. Now, a series circuit here has only one path in which the current can flow. So in a series circuit, the current flows through one single path and the current remains undivided here. That is, the same current flows through R1, R2 and R3. As you can see, I is same everywhere. So I is equal to I1 is equal to I2 is equal to I3 because the current is not getting divided anywhere since it is a series circuit. So now what will happen if one of the lamp is being removed from this circuit? So we are seeing here three lamps are connected in series and a battery is there and a switch is there. Just assume if one of the lamp is disconnected from here. So what will happen to the next lamps? Yes, the answer is the rest of the lamps will not get the current flow and hence all the lamps will turn off. Just pause and think. Okay. So what about the lighting circuits in your house? Do you think they are connected in series? What will happen if one is disconnected? Just assume the scenario. Like in your house, if any one of the room gets a shortage of power supply, the power supply just turns off. Do you think the other rooms will also get turned off? No. So what is the solution for it? So how should the lights be connected? And the answer for that is that the current should flow in parallel. Because just see here, there is a battery source here, there's a switch here, and there is a current flow here. So when the current flows here, it actually divides into three in the parallel circuits. So it is I1, I2 and I3 for the resistors R1, R2 and R3. Now just imagine these resistors as a lamp, lamp 1, lamp 2 and lamp 3. Even if one gets disconnected, the rest of the lamps will glow because the current still flows as the connection is in parallel. So a parallel circuit has more than one path for the current to flow. And here the sum of the current, the total current I is nothing but the summation of I1 plus I2 plus I3. Also, the current, as I gave the scenario here, just imagine the load resistors with the lamps. So again, what will happen? The answer is Though one lamp is disconnected, the current still flows through the other lamp. So this is just a picturization for you in order to see how the current flows in the parallel circuits. Okay. So in the figure shown, AB is a copper wire which is connected to point A and B in the circuit. So we were speaking about this circuit. Since the copper wire has very little resistance, therefore a large amount of current will flow through it. Just think about the situation of a short circuit. The lamp then goes off. So why? Therefore, we say that the circuit is now a short circuit. So I was just telling that AB is a copper wire. This is AB, and this AB has a very little resistance. And what happens if the large amount of current flows through it? So there, the lamp does not get any supply. So why does this happen? Still, it is connected in parallel only. So as per our assumption, we should know that though the current flows here also, the current should flow here also. But why is the lamp not getting the current? So we'll discuss about that in the forthcoming sections. So this is called as the short circuit. In the short circuit, after this low resistance line, there will be completely no flow of current. Hence, this lamp gets turned off. So coming to the summary, a series circuit has only one path for the current to flow, and the current is the same throughout the circuit in a series circuit, whereas in a parallel circuit, it has more than one path for the current to flow, and the current in general is different at different points of a parallel circuit.